Hello, and welcome to an in-depth exploration of the science that powers our world. Have you ever considered what drives the changes and movements we observe in our daily lives? What is the fundamental force behind these phenomena? Why do things move, change, or light up? The answer lies in energy. Energy is the essential element in every action and reaction. Energy acts as the unseen force that powers everything around us. It's present in the wind that blows, the electricity that illuminates our cities, and the fuel that drives our vehicles. It's the capacity to perform work or bring about change. Whether it's a person working diligently or a machine operating efficiently, energy is at the core. Without energy, everything would come to a halt. Imagine a world where nothing moves, no machines run, and no life exists. That's a world devoid of energy. Consider this. When you kick a soccer ball, you're transferring energy from your leg to the ball, causing it to move. That's energy in action. Every movement you make is a demonstration of energy being transferred. Thermodynamics is the study of how this remarkable force, energy, behaves and transforms. Scientists and engineers utilize thermodynamics to understand and harness energy in various ways. It helps us comprehend how energy flows and changes from one form to another. For instance, how the chemical energy in food becomes the kinetic energy that enables us to move. Energy is omnipresent and inherent in everything. From the solar panels that capture the sun's energy to power our homes, to the bustling city lights that brighten our nights. From the sun that warms our planet to the food that fuels our bodies, it's the invisible force driving our universe. Every bite of food you consume is packed with energy that your body uses to function. So, join us as we delve into the fascinating world of energy and its various forms. We'll explore how energy is generated, transferred, and utilized in our daily lives. Keep your safety glasses on. Things are about to get intriguing. We're going to uncover the secrets of energy and see how it shapes our world in ways you may not have imagined. Let's start with a form of energy you can feel, thermal energy, also known as heat. It's something we encounter every day, whether it's the warmth of the sun on our skin, the heat from a stove, or the cozy feeling of a fireplace on a cold night. This type of energy is all about the movement of tiny particles called atoms and molecules that make up everything around us. These particles are in constant motion, and the energy they possess due to this motion is what we refer to as thermal energy. The faster these particles move, the hotter an object gets. When you heat something up, you're essentially making its particles move more vigorously. Think of a pot of water on a stove. As the stove heats the pot, the water molecules inside start to move faster and faster. The stove transfers heat energy to the water molecules, making them jiggle and vibrate faster, increasing the water's temperature. This is why you see bubbles forming and rising to the surface as the water boils. But how does heat travel from one place to another? Understanding this is key to grasping how thermal energy works. It does so in three main ways: conduction, convection, and radiation. Each method has its own unique way of transferring heat. Conduction is like a game of molecular tag. Heat energy is passed from one molecule to another through direct contact. This is why a metal spoon gets hot when its handle is left in a pot of boiling water. Convection is like a hot air balloon. Heat travels through the movement of fluids, like air or water. This is why warm air rises and cool air sinks, creating currents that distribute heat. Finally, radiation is like the sun warming your face. It's the transfer of heat through electromagnetic waves. Unlike conduction and convection, radiation doesn't require a medium to travel through. Understanding thermal energy is essential in our daily lives, from cooking our food to designing buildings that keep us warm in the winter and cool in the summer. It's also crucial in various technologies and industries. It's all about managing the flow of heat. Whether it's through insulation, ventilation, or using energy-efficient appliances, controlling thermal energy helps us create comfortable living and working environments. So, next time you feel the warmth of the sun or the heat from your stove, remember the fascinating science of thermal energy at work. It's a fundamental part of our world, influencing everything from weather patterns to the comfort of our homes. Ready to get things moving? That's mechanical energy, the energy of motion and position. This type of energy comes in two flavors: kinetic and potential energy. Kinetic energy is the energy of motion. Anything that moves has kinetic energy, from a speeding car to a spinning top. On the other hand, potential energy is stored energy due to an object's position or state. Think of a stretched rubber band or a book held high above the ground. These objects have the potential to move and release energy. When you let go of the rubber band or the book, potential energy converts into kinetic energy. Mechanical energy and thermodynamics are closely linked. The laws of thermodynamics govern how mechanical energy is converted into other forms of energy, such as heat or sound, and vice versa. Section 4. The shocking truth about electrical energy. Hold on tight because we're about to explore the electrifying world of electrical energy. This form of energy is all about the flow of tiny charged particles called electrons. Electrical energy is what powers our homes, lights our cities, and runs our gadgets. Electrical energy is generated in various ways, such as using turbines powered by steam from burning fossil fuels or harnessing the power of flowing water in hydroelectric dams. Another fascinating way to generate electricity is by using thermoelectric generators, which convert heat energy directly into electrical energy based on the Seebeck effect. Understanding electrical energy is crucial in today's technology-driven world. From the circuits in our smartphones to the power grids that supply electricity to our homes, it's a fundamental part of modern life. Section 5. Chemical energy. It's bonding time. Let's dive into the microscopic world of atoms and molecules to understand chemical energy. This type of energy is stored in the bonds that hold atoms together. It's like hidden energy waiting to be released. Think of it like the energy stored in a battery or a delicious slice of pizza. When chemical reactions occur, like burning wood or digesting food, these bonds are broken and reformed, releasing the stored chemical energy as heat, light, or even electricity. For example, when we burn fuels like wood or gasoline, we're breaking the chemical bonds within them, releasing the stored energy as heat and light. Chemical energy plays a vital role in our lives, from the food we eat to the batteries that power our devices. It's the energy source that keeps our bodies functioning and our modern world running. Section 6. Nuclear energy. Small atoms, big power. Get ready to unlock the immense power stored within the tiniest particles, atoms. Nuclear energy comes from the nucleus, the very heart of an atom. This energy can be released through two primary processes: fission and fusion. Nuclear fission is like splitting a heavy atom, like uranium, into smaller atoms, releasing an enormous amount of energy in the process. Nuclear fusion, on the other hand, is like combining two light atoms, like hydrogen, to form a heavier atom, releasing even more energy than fission. This is the process that powers the sun and other stars. Nuclear energy has the potential to provide vast amounts of clean energy, but it also comes with challenges, such as managing radioactive waste safely. Section 7. Energy transformations. It's all connected. As we've explored the different forms of energy, it's essential to remember that energy doesn't just appear or disappear. It is a fundamental principle of physics that energy is conserved. It transforms from one form to another, obeying the fundamental laws of thermodynamics. These laws govern how energy moves and changes, ensuring that the total amount of energy in a closed system remains constant. Think of a car engine. This everyday example can help us understand the complex processes of energy transformation. Chemical energy stored in gasoline is converted into thermal energy through combustion, a process that releases heat and light. This thermal energy then gets transformed into mechanical energy to move the car, powering the pistons and turning the wheels. Understanding these energy transformations is crucial for designing efficient and sustainable technologies. Engineers and scientists work tirelessly to improve these processes, making our machines and devices more energy efficient. By understanding how energy flows and changes, we can harness its power for the betterment of humanity and our planet. Renewable energy sources like solar and wind power are prime examples of how we can use our knowledge of energy transformations to create a sustainable future. So there you have it, explorers of science. The journey through the world of energy is filled with endless possibilities and discoveries. We've journeyed through the fascinating world of energy, exploring its many forms and transformations. From the warmth of thermal energy to the microscopic power of nuclear energy, each type of energy plays a vital role in our daily lives and the functioning of our universe. Remember, energy is everywhere, constantly changing and shaping our universe. It powers our homes, fuels our cars, and even drives the natural processes that sustain life on Earth. Keep your curiosity alive, and never stop exploring the wonders of science. The more we learn about energy and its transformations, the better equipped we are to innovate and create a brighter, more sustainable future for all.